Hi guys, welcome to my channel. In this tutorial, we're looking at the integral of x to the 5 all divided by 2 plus x to the power 12. This is MIT integration B question. So let's tackle it. So first, the integral of x to the 5 over 2 plus x to the 12 dx is equals to the integral of x to the 5 over 2 plus, but with this one I'm going to split it as x to the 6 power all squared dx, and then I'll use a u sub from here, because 6 times 2 is 12, which is the same as the power of x in the denominator. So let's use a u sub here. So we can let u be equal to x to the 6 du dx is equals to 6x to the 5. That implies du is equals to 6x to the 5 dx. So I can divide here by 6, divide here by 6, and I'll have du over 6 equal to x to the 5 dx. Now, our integral of x to the 5 over 2 plus x to the 6 dx can be written as the integral of 1 over 2 plus x to the 6 squared times x to the 5 dx. This can also be written as this. So we can take everything from the x world into the u world. So that should become the integral of 1 over 2 plus x to the 6. X to the 6 is u. So that's u squared times x to the 5 dx. X to the 5 dx is du over 6. So 1 over 6 is a constant. It comes in front. Integral of 1 over 2 plus u squared du. So we are going to use another sub from here. This is now a trig sub tangent. So we can let u to be equal to square root of 2 tan of theta. We can't let u to be equal to 2 tan theta because the square of 2 is going to be 4, which is not matching with the 2 here. So the square of the square root of 2 is 2, which will help us to factorize the 2 out and use the Pythagorean identity of trig. Now let's take our integral. So let's find du. So du d theta is equals to square root of 2 secant square theta. Du is equals to square root of 2 secant square theta d theta. Now our integral in the u world, which is 1 over 6, integral of 1 over 2 plus u squared du is equals to 1/6 integral of 1 over 2 plus u squared. What is u? U is square root of 2 tan theta squared times du. Du is the square root of 2 secant square theta d theta. So that becomes 1/6 integral of 1 over 2 plus square root of 2 squared. So that's 2 tan theta squared is tan square theta times the square root of 2 times the secant square theta d theta. Next, 1/6 square root of 2 is a constant. It comes in front. The integral of 1 over 2 is constant. In both terms, you can factorize that one out. I love it. 1 plus tan square theta times secant square theta d theta. So we know from our trig identity which is secant squared theta is equals to 1 plus tangent squared theta. So we can just plug that in. So that should be square root of 2 over 6 times 1/2 is a constant. It comes in front, then integral of 1 over secant squared theta. This is secant squared theta times secant squared theta d theta. So that simplifies to the square root of 2 over 12, the integral of 1 in the theta world. So that is equal to the square root of 2 over 12 times theta. I have to move from the theta world back into the u world. U is equal to square root of 2 tan of theta. U is equal to the square root of 2 tan theta. Let me be sure. Yep. So we can find theta here. These cancel. Tan theta is equal to u over the square root of 2. Implies that theta is the arctan or the tan inverse of u over the square root of 2. So we can plug that in here and get our integral. So our integral becomes the square root of 2 over 12 times theta. Theta is the tan inverse of u over the square root of 2. We now have to move from the u world back into the x world. So what's u in terms of x? All the way up, u is x to the 6. So it means wherever we see u, we just plug in x to the 6. That is from here. We know that u is equals to x to the 6, which you can just plug back in here. And we get our integral. So that should be square root of 2 over 12 the arctan of x to the 6 over the square root of 2. And this you are done, but you can do some rationalization here. Over 12 times the square root of 2. I'm just rationalizing the numerator, x to the 6 over square root of 2. So this is 2 over 12 root 2. The tan inverse of x to the 6 over square root of 2. This can further be written as 2 1 over 6 root 2 tan inverse of x to the 6 over root 2, just to make the equation a little nicer. But you can stop from here. But this is much more, it's much simpler. So our integral, which is the integral of x to the 5 1 over 2 plus x to the 12 dx. The value of this integral is 1 over 6 square root of 2 arctan of x to the 6 over the square root of 2 plus c. And this is it. Again, as we always do, if you take the differential of 1 over 6 square root of 2 tan inverse of x to the 6 over root of 2 plus c, we should be getting our original expression under the integral, which is this one. So that's it. If you find this video helpful, make sure to like the video, subscribe to my channel, hit the notification bell for more content. I'll see you in the next one. Bye bye.